Okay, I'm Tyler, and let's just get some of the really crazy questions and issues out on the table first. Why is a guy at a JavaSIG talking about Ballerina, a different programming language? First, it's a JVM-based language. It's implemented on the JVM here. Second, I come from a company, WSO2, probably, does anybody know this company? A couple of you? All right. We are now the 6th largest open source software company on the planet. We make a lot of integration software, and we've done it all from scratch, built it in Java over 14 years here. And so Java is at the heart of everything that we've done. We've been a big backers on that. And prior to my current career here as the CEO of this company, I started off my career at BEA in the 90s, and I wrote 3 books on Java. My career was pretty much made with Java, so I've grown up and lived with it. So there's a lot of relevance to what's going on with this. And given that the products that we've made over the years have been heavily based upon Java, the designers of this particular language were heavily influenced by the types of things that they've experienced. We have roughly, we'll end the year with about 450 enterprise customers. Our main competitor is MuleSoft. We're a pure open source alternative to what MuleSoft has. And we've worked on about 2,000 projects. Our software today powers about 6 trillion transactions a year. So highly scalable, very available, high throughput capabilities. And so we have a range of stuff: API management, enterprise service bus, message broker, a string processor. We have a number of technologies in and around that. But Ballerina, and please forgive me in advance. I am a CEO that is going to do live coding demo in front of a bunch of Java experts. So if I leave this room standing, that is a good night for me. Okay. So I just had to get that qualifier out of the way. All right. All right, so we're just going to talk about the language. We're going to talk about the fundamentals of the language, why it was designed. We're going to give some demos, live demo coding here, and then up for Q&A. And hopefully, I'll do this so efficiently that we get some time back for Gene and keep us back on schedule. Okay, so a quick 3-minute overview. What we've seen over the past 5 decades is that companies have such consumer demand that in order to meet that consumer demand, they have had to scale their systems to levels that they didn't previously anticipate. And in order to scale systems, what we've seen is that architectures have increasingly been disaggregated over time. And what we talk about as the API economy or API-driven development is definitely a step in that direction where we have started to componentize these solutions in such a way so that they can be more independently iteratable and more independently scalable. And serverless and microservices is another step in that direction where we're seeing more of these components that are created. This disaggregation is leading to more endpoints being generated, right? And these endpoints, by their very nature, since they have an API on front of them, they are programmable. And so this is an exponential curve. So what's happening is that everything that we're generating, functions, whether it's a formal API, some sort of data exposure, a SaaS legacy app, everything that we're generating is by definition becoming some sort of programmable endpoint. Right now there are roughly 50 billion programmable endpoints on the planet, and we're probably going to see those grow to about 1 trillion in the next decade. So 1 trillion programmable endpoints. So we come from an integration world, and integration, just quite simply, we define integration as the resilient communication between endpoints on that. And we talk about integration as kind of the plumbing of the world. There isn't a lot of discussion about it. There's a ton of discussion about microservices or serverless architectures or perhaps event-driven architecture. But integration is really the discipline of these technologies down below. It's something that's been around for the past 5 decades. It's going to continue to be around. Here's a startling statistic. Gartner just came out and said that in 2020, 50% of all the time and cost that goes into digital platform projects or digital transformation projects is going to be related to integration. And they think that this statistic is going up. So integration is pretty much everywhere. It's what we have to deal with in our life. And as the number of endpoints increase, dramatically, we're going to have to deal with it a lot more. So because these endpoints have existed, we noticed that there was this integration gap that was starting to develop. And the integration gap really exists between integration products like we build at WSO2, ESBs, BPM, and EAI, versus general purpose programming languages. And these are the two most common approaches to doing integration today. On the one hand, with integration projects, you get a lot of integration competence. You get transactions, you get compensation, there's data transformation. But all these products today are config over code. And the thing about config over code is that it creates for a very non-agile-like process. Developers generally despise these products. Nobody ever woke up in the morning and said, I cannot wait to be an ESB developer today on that. But they're scalable. They provide a centralized environment. There's a central form of control and governance on that. So they are predominantly what's deployed for large-scale integration projects because of this center of excellence capability that's there. On the flip side, we have general-purpose programming languages like JavaScript, Go, and Java. Oftentimes, to provide integration capabilities, they add on frameworks associated with that, or they leave the hard problems of integration up to the developer themselves to add in for whatever use cases that are there. So you get a total agility capability with that, but it's not very integration-friendly or integration-simple. So we call this the integration gap. Ballerina is a programming language that is designed to solve this gap. It is intended to be both agile and at the same time integration simple. Right? It's a compiled language. It's type safe. It's strongly typed. It's also a concurrent language. Right? And the tagline that we use for it is that it's designed to make it really easy to create microservices or really easy to write anything that talks over the network to an API. There was a great quote. Kevin Hoffmann, he's here in New York City. He works in the CTO office at Capital One, and he described, I think, Ballerina better than the way we describe it. And he said, look, he's facing this world of service fatigue, and that he's a big Go developer. He's also a big Spring developer. And whenever he has to build an API, there's all these libraries and scaffolding that you have to drag along with it, just so that you can get to the point of starting to write your service. And I never heard that phrase before, but then, after doing a couple of projects, he started blogging on Ballerina, and he used this sentence here, and I thought this was a fair reflection of why we designed the language and what we hope to gain out of it. And the goal is to make it really simple to create APIs that talk to other APIs without all that sort of scaffolding, but still maintaining these other qualities. The language itself, there is about 100 people that are committing and contributing to this language at this point in time. So it's a pretty sizable project. It started about 3 years ago. It started off 3 years ago with a very small group of people focused on just trying to see if there was an easier way to program against ESBs. And they came up with some design principles, and we'll walk through what these design principles are. But the one that's most important here is this idea that when you're talking to an API, you need a type system that really appreciates and understands the network. If you're going to go and talk to, for example, the Twilio API, a single API call is going to not just have a protocol associated with it, but the data that can come back oftentimes can come back in many different formats. There could be an error, there could be a data structure inside of it. That data structure could have different formats. And so having a type system that just treats one type as one type is not very conducive to network programming. And one of the fundamental things that's in the language is a union type system. And what I mean by a union type system, and you'll see it, is that a variable can be declared as a string or an int or an error. And so any one of those things can come back, and then there's a way for you to detect which of those things it is. And so the compiler can appreciate that. And so when you're talking to something over the network, this eliminates all sorts of scaffolding code that you don't need because the system supports union types out of the box. Another very important thing that's in the language is that JSON and XML and tables are primitives. right? You'll see in the language that writing JSON is as simple as just writing a JSON object in the code. You don't have to quote it. You don't have. There's a bunch of things that you don't have to do, and the same sort of thing for XML and tables, because these are pretty fundamental constructs that you do when you're talking over the network. So with that, that's enough talking. Let's pray here. Let's do a hello world. Now, I'm going to actually write this one from scratch. All right. VS Code. Anybody have VS Code? Yeah?
Why is it called Ballerina?
Why is it called Ballerina? It's a wonderful question. And before I answer that, I have to tell you that we had our first BallerinaCon a couple weeks ago in San Francisco. We had 300 people attend. And at that conference, we announced a collaboration with the San Francisco Ballet, and they performed on stage. And they told us, we made a charitable contribution to them. They told us that we are the first tech company ever in 50 years in Silicon Valley to have made a charitable contribution to the San Francisco Ballet, which is the oldest ballet in the United States of America on that. How is that possible that it's Silicon Valley? Anyway, so we got videos up. They had these professional dancers come. It was awesome on that. But anyways, it's called Ballerina because when you write a microservice that's going to talk to a bunch of APIs and you need to do it in an orchestrated way, that's a dance. And ballerinas are the epitome of an orchestrated dance.
And also you walk on the toes?
They point, well, the logo, if you notice the logo, that's the on point. The logo is brilliant on that. It's related to the shoes on the toes there. On that. But that's why it's called Ballerina, the language.
It's not orchestration, it's choreography. Actually.
Well, there's choreography and orchestration, and there's a bunch of different components that go along with that. But yes, thank you for the. I just lost a hand. All right, so VS Code people, everybody's IntelliJ in here, aren't they? All right. Anyways, we have an IntelliJ plugin for this. This is VS Code because I find it quite reasonable. So oops. All right. I've got to save this to get my handy old code here. So the first thing is that we're going to write a service, okay? A service in Ballerina is a first-class construct. In most programming languages, there's only one entry point. It's a main method, right? A main method is your functional entry to that. In Ballerina, there are two different types of entry points. You can do a main method. You can actually do pretty much any method. You have this way of picking a method and it can become an entry point. Very classic procedural programmatic way of doing things. But services are also an entry point. And a service is exactly what you expect it to be. The compiler is going to take this service and compile it into a runnable server that will execute and run as a small hosted service against some sort of protocol. In this particular case, we're going to do the HTTP protocol, and so this came from the HTTP package that's up there. And we're just going to declare this as an HTTP service for now. And we're going to give it a name. And a resource is the function that's going to be invoked. So really, what this basic code here is doing is that when we get done with this service, which is going to be a registered API, I want to do :host, we'll do 9090 hello/hi. Now, right now that returns nothing because there's no server there. But in this particular case, because it's hello and hi, this service is going to work for us in that regard. So you've got some other objects that are going on here. You've got a request object, which reflects the request that came in from the caller. And then you've got an endpoint. And an endpoint is another major important concept in the language. In this case, an endpoint represents a networked destination. Now, when you're programming across a network, there are three types of endpoints that you need to care about. One is yourself. You yourself are an endpoint because you're a network location as a service. Another one is the caller, to somebody who's calling you. And so this endpoint is passed in. So if I need to talk back to the person who called me, I can use the caller object here, which is an endpoint, and talk to him. And then the third type are other endpoints that you declare as either global or local variables. And those endpoints represent network locations here. And if we wanted to, we could come up here and we could create an endpoint, and of various types. And there's all kinds of different protocols for different endpoints that you declare, and you give it a name, and then it's an accessible variable that you can use elsewhere in your programs on that. Now, just to save myself a little bit of time, I'm going to pull this one up and save myself some code here. Typing, because we're hurrying. And what did I do with my Tyler? There we go. All right. We'll paste that in there. Okay, so we're going to create a response object. We're going to then set the payload to the response with just a string, hello world, JavaSIG. And then, when we're done with that, we're going to send that response object back to the caller. And so here's a caller. And what I want to point out is that in most languages, dot syntax represents both local and network. In Ballerina, if you want to talk over the network, you use arrow syntax here. And if I could actually remove this respond, and I could do the control thing, and you can see that even the language support understands this. And the caller object can have local methods or remote methods, but it's going to respond over the network. And there's a very particular reason for this, and I'll show you in just a minute. Put a semicolon there. And this underscore is Go syntax, which just says ignore anything that comes back on that. So this is about, as simple as hello world that we get. Still not curled anywhere. So now if I want to run this, I can do a Ballerina build, or I can, to compile it, or I can just do a run, and this will both compile it and then run it. And when it's done there, it should tell us that, oh, this is really slow. It did exactly what it's supposed to do, because I didn't bind our service to a port. So this is also an endpoint, and you need to bind your service to an endpoint. I could either declare that endpoint or bind it. Yes. There we go, thank you. There we go. And so now, right? So pretty simple stuff. Now, why was this an arrow and not a dot? So one of the interesting things is, if you've done integration projects, integration specialists talk to one another using sequence diagrams, right? This is how we follow the flow of communication from one location to another. The syntax, the whole structured syntax of the language itself is designed to always be able to generate a full sequence diagram for this. So I just clicked that guide up there, and this was generated from the code on that.
Hey Tyler,
Yep.
can you kind of make it the font larger?
Bigger? Even
Yeah.
larger, no problem.
So people in the back can see it.
Is that better, Brad?
Yeah. Can you guys see it in the back? Is that better?
Yep.
Okay.
Okay, sorry about that. Yeah. All right. So there's a sequence diagram here, and if we wanted to, for example, just come over here, and I created a hit. You'll see that without having done anything, there's now another resource down here that's showing you the interaction of that. So, but part of that is it recognizes that local calls are dots, arrow calls are network calls. So, okay, all right, so we've done that. Now, it's like, okay, well, what if we didn't really like the fact that we did it over curl? What if we wanted it to be a post method, and what if we wanted to not have it be that map? Okay, it's there. So annotations are built in, very familiar to Java developers, and this would be methods. Oops, dude. Base path. That, and it's a slash, and we can come in here as well and add a resource config. The HTTP resource config, and this is methods or post, and path is So do that. There we go. Rebuild, rerun. Ah. Okay, and boom. Right? So we've annotated the language. So no scaffolding. If we wanted to compile this, first kill it, and I would do a Ballerina build tyler.bal. That's going to create a balx. That is, we have our own bytecode at this point in time. And the bytecode runs in a highly modified JVM that we run. We'll have an LLVM implementation of this so that we can compile down to native binaries soon. But if I were to just do an ls-al on tyler.balx, this file was about 197K in size to run that servers that's there. Okay. All right. So basic hello world. Maybe not all that exciting. So let's do something much more exciting, which is to, and I'm just going to load some code, and I assume that everybody can read the code. Let's do some integration work here. All right. Let's see here. We want to do this one. All right. First, if we want to do some integration, we're going to import some other package. And in this case, we're going to talk to Twitter. We want to just send a basic message to Twitter. So we talked about endpoints as potentially being remote locations that you want to talk to. So here, this is declaring an endpoint. The protocol is of type Twitter client. And in this particular case, there are 2 secrets and 2 tokens that Twitter requires. And so this is going to use a config package to get those keys. And I'm going to pass those keys in on the command line once we compile that. Once we have that, if you notice, it's giving me all these sort of squigglies. And what this is telling me is that I'm not aware of a Twitter package anywhere. So I can come and do a Ballerina search Twitter. And that hits Ballerina Central, which is a shared, a shared registry that has packages inside of it, and there's a WSO2 Twitter package there. We've built in a build management system. We've got our own registry that's built in. The versioning is taken care of. We haven't delegated that to the ecosystem because we found that when you delegate these sorts of things to the ecosystem, you run into all sorts of issues about the best way to deal with versioning, the best way to deal with transitive dependencies. And so we've just baked this in. This is all Apache licensed. This is all open source, so there's no issue with vendor lock-in. But because this package is there, it uses Docker semantics to be able to pull a package. I could either compile build the system and it will download it, or I can pull Twitter. And there we go. Now it's got it downloaded here. And maybe I need to reload it. There we go. And so now, because that package is in my repository, all the squigglies have gone away. So we still have our service. It's still called hello. It's still bound to port 9090. It's still going to be a post. The difference here is that now we've got a response. And now we're going to get a payload from the request. So we're going to pass in a payload. And so this means we want to do curl-x post-d, and we'll say JavaSIG here on that. And then what we're going to do is we're going to take that payload and send it to Twitter, right? So in this case, there's that Twitter object that we created above, and we're going to tweet it over the arrow, right? So this Twitter package came with a function called tweet, and it's just going to pass in the payload. Now, if you notice, in both of these cases, they have this weird check thing that's going on here. And that's there because if we remove the check, we're going to get an error code. And what it's going to tell you is that it's an incompatible type. And it expects a string and found string or error. And so what this is doing is this is an example of the union type system. So on the left-hand side, we're expecting a string, which is a payload on this. But the request.getTextPayload method returns a string or an error. That's the actual type. So I could fix that in one of 2 ways. I can go string or error, here, and this is legitimate syntax. Now I've got a variable which is a string or an error. And then I have to type match it down and narrow it down to the right one to be able to work with it. Or we can do the check operator. And the check operator says, look, if it's a string, great, let's continue on. If it's not a string, propagate it up the call stack and deal with it as an error condition up there. And so this is some syntactic sugar as an operator that makes dealing with union types really simple. There's other things that you can do as well, which is there is a really interesting match keyword. And think of a match keyword as like a case statement, but whereas case statements look at the value of a variable, a match statement will look at the value or the type. And so you can match and say, if it's an error type, then do this. If it's a string type, then do this. If the value is this, then do that. So you've got this match capability there. And if we remove the check here, we'll see that the Twitter tweet, it expects, in this case, either a Twitter status object or a Twitter error object, right? And in this case, we're only getting the Twitter status object, so we're going to just check it again. And in this case, we're going to take that status, we're going to set the payload, and then we're going to respond back with that. So in this case, I'm going to run, this was 3, right? And I'm going to pass in a Twitter file to a demo account that we've got. Good, it's running. And so now it says, great, it tweeted the JavaSIG. And assuming that everything is running, get back to my browser, Twitter, is it B7A? We have this, oh, I'm sorry, let me search. B7A demo. It's this account that those credentials map to, and you see JavaSIG there. All right, so only a little bit of code, we've done that. All right, now let's amp up our game because I want to really give Gene Becker some time. Let's do a transformation on that. And also let's compile the service so that it's ready to run in Kubernetes all at the same time on that. So interesting thing, we've come to the belief that once you recognize that you're going to be writing a service that's talking over the network and that it's intended to talk over the network, there's a bunch of architectural things that have become commonplace that people now expect, such as people build directly into a Docker image. Or heck, if I'm writing this service, I might be running it in Cloud Foundry, or I might be running it in Kubernetes. And so hiding those architectural awareness elements to be deferred to CI doesn't make a lot of sense to us. And so we've built in mechanisms so that you can keep the developer into a single code file and have it statically checked. So in this particular case, we're going to import a Kubernetes package. And the Kubernetes package brings along annotations that are specific to Kubernetes. And these annotations, which you can write yourself or you can use the imported ones from third parties, the annotations give instructions to the compiler, and the compiler will generate artifacts for deployment into any number of different environments as part of the build system on that. So we still have our Twitter endpoint. Now what we're doing is we're annotating the endpoint. So this endpoint is going to represent our service. Before it was that bind 9090. Now we've just pulled it out as a variable named listener here. And a Kubernetes service of type node port. This is an instruction that says, look, our service is going to be get these artifacts for Kubernetes when we build it. We're going to do the same thing for the service itself. We added these deployment, and we've added the config map. So this is my Tama with all my Twitter secrets and accesses inside of it. So just a couple of annotations. We still have our service. We still a basic resource path, still the high. We still get the text payload from over the network. Now we're going to do some data transformation on that. And so it's just using string manipulation. And then after we tweet it, instead of us just printing out that Twitter status object, we're going to create a JSON. And I told you that JSON was a primitive. And this is an actual JSON object. You just type JSON, you give it a variable name, and then you open up the curly brackets here. And these are the keys that you want. You just type in the keys, no double quoting. And then the things on the right can be records, they can be other objects, they can be values, and you just paste them in. once you have a JSON or an XML or a table, they're all forms of maps and unions, and so you can cast from one to the other. You can go from JSON to XML, XML to tables, and it's just automatic as part of that. And then, once we've done this, we've taken this JSON, now you're going to send this JSON response back. And so now there's this new keyword here, untaint. And if I remove that, you'll see that we get a syntax error here. And one of the design principles of the language is that we know enough about what constitutes security issues in programming languages that the designers are attempting to make the language secure by design. And so in this particular case, what happens is that we assume any sort of data that may be going, that could be vulnerable to penetration is considered tainted by default. And a developer has to explicitly say that this is an untainted variable, so that there's no form of SQL injection or whatever other penetration that you might have there. And so in this particular case, because you can set a payload, this function knows that any data that's coming into it has to be untainted. And so the developer has to explicitly say, untaint here, to clean that variable and to get it to compile in the end. So there's a whole series of mechanisms that we call secure by design that's available in and around that. So now if my Control-C is just not very functional today. There we go. Okay. I've got Kubernetes running on Docker or Edge here. So now if we were to Ballerina build this file, in this, you will see that not only did it compile it into a balx file, but it's gone through and processed all those annotations. And if I do a tree here, you can see that in addition to the balx, we've got a Kubernetes folder. And if I were to go into the Kubernetes folder, there is a bunch of YAML in here. And so this YAML is what is needed to deploy to Kubernetes. So I'm just going to go back up and grab that statement. We're going to control apply. And so this is deployed into my local Kubernetes. And so now if I do kube control get services, there should be something that's been up for 10 seconds. And you'll see that this service, that port 9090 is mapped to 31362. And now it's responded back with that JSON object. And if we go back to my thing here, you'll see one entry, JavaSIG and Kubernetes on that. All right. There's a lot more to the language that's going on here. Let me just get back to, first of all, I can bring open our handy graphic, and you'll see that it's a much more sophisticated sequence diagram now of what's going on. Right? You can see that it's added the Twitter endpoint that it's talking to. This is a remote call. These are local calls with data transformation in the middle of that. Okay, all right. So, to the good stuff. The connectors. Docker Kubernetes. All right. All right. So there's a lot more going on to language. One, in the case of observability, the binaries by default can have zipkin or open tracing parameters built into them. If you write multiple services in Ballerina and those services call one another in a chain, the tracing IDs are automatically propagated. Same thing happens for microtransactions as well. You'll see that there's a transaction block, so you can write two-phase commit transactions or local transactions. So the transaction context is automatically passed along. This is a Jaeger output that you just plug in to the binaries that you've written, and you can see the tracing metrics over time. Same sort of thing with metrics. You can use Prometheus and Grafana And these are all configurable as part of your runtime config on that. And same thing with logs. And so it's these capabilities of talking over the network, the nature of the concurrency mechanism, the sequencing, and these cloud-native extensions for why we all rolled it up and said, hey, it's a cloud-native programming language. There's a lot more going on. Built into the language is a whole series of resilience mechanisms. So load balancing, when you talk to an endpoint, it's just as simple as an annotation on that. You can do failover, you can do various types of circuit breakers, which basically trigger on-off communications to a remote endpoint based upon the stability of that endpoint. These are all just based simple annotations that you add, and then the compiler takes care to build the right runtime environment to operate that. Asynchronous programming is also built in. A very simple model where you can start processes to work in the background. There is a worker-based concurrency model. It's very different than the Java one thread per class. In a worker-based concurrency model, it's closer to the way Go does it, where each worker gets allocated one thread, and you can define as many workers as you want. And if you've ever done any sequence diagram programming or integration programming, worker models are how sequence diagrams reflect it. Same thing with Swagger generation. We showed you the sequence diagrams as well. And the natural question, how does this compare to Spring? Our big thing here is that there's a lot of great things that Spring does, but if you're specifically looking to do complex mediation, logic, and routing, there's a lot of boilerplate code. There's probably some sort of XML for the routing, plus Maven and Gradle and stuff like that. And our whole design principle was to try to get all this down into a single Ballerina file, and then as long as it was syntactically correct and it compiled, you were done and you're guaranteed for it to work. So as a result, we think of Ballerina as kind of like the glue between microservices. Write your microservices in Java, JavaScript, Go. Use this as a glue. This is running in production environments at this point in time. There is large Fortune 500 companies who are running this, believe it or not. They will become referenceable fairly quickly at this. The people who are using it, they're using it to write various forms of APIs for backend systems. And also we have DevOps and sysadmins who are using it as an alternative to Bash. If you're doing a lot of scripting where you have to talk to a system over an API, sed, awk, Perl, Bash is not as easy as just kind of scripting this out and then deploying it down. And it's self-documenting because the graphics say it so. We've worked really hard to build in all the protocols that you could imagine and all the sort of connection endpoints. So a lot of event-driven endpoints are available here, a lot of different protocols. Access to a database is also very similar to an endpoint. I talked about how table is a primitive in the system, so if you're going to talk to a database, SQL elements and tables are very natural, much the way that JSON and XML is. One of the great things the engineers have done, if you go to on the Ballerina site, there's a Ballerina by example. It's got like 150 examples, short code snippets of every possible thing you might want to do. We talked about some of the things up top, but there's a lot more going on in the language underneath the covers here. Particular of interest, like if you really wanted to geek out, check out the streaming examples. So if you've ever done any complex event processing where you write a stream that's processing events over a window in a stateful manner, there's usually separate products for that. There's about 15 companies that build products for that, and they're treated as a complete form of middleware. Ballerina has that built in. There's a concept of a forever block, and if you just write a service and you put a forever block in there, that forever block gets attached to some event stream, which is coming from the inside or from outside source, and then you can do stateful streaming SQL right there in that block, and the compiler will generate a minimized service that will its whole job is just to process those events and do it as scalably as possible on that. So it's pretty cool built into it. Again, transactions are a pretty fundamental part of the system, and by the end of the year, we'll actually let you write stateful APIs as well. So much the way that a BPM system lets you do long-running workflows, you'll be able to write a service, and you'll be able to designate methods or data as persisted, long-term persisted, and the system will automatically take its call stack, persist the call stack to a persistent store, and then if in the future there is another invocation such as a human or another computer that says revisit this workflow and continue it on, it'll recover naturally off the call stack, off the disk, and pick up where it's left off. So you don't have to go into some sort of BPM system and do a completely different style of programming. You just write your service, you just tag certain things as persistent state, and the system will take care of the rest beyond that. All right, we're a commercial vendor, right? So if for any reason you wanted to experiment with it, we would be happy to come do free training. We're offering commercial support for it as well. Obviously, it's a new community. We're bootstrapping it, so we get that there's a lot of risk associated with that. But we're making a pretty big bet on this, and we think it's pretty fun along the way. And with that, awesome. Thank you. Questions? Let's go. Yeah. The demo, I was able to code the demo, and I fixed the syntax errors. Please. I'm sorry, I think he was a little bit heavier.
Yeah, quick question about the runtime. You mentioned you're using modified JVM. What were the modifications while you're moving to LLVM?
Yeah, the modifications on the JVM were a different threading model, a different scheduler, a different memory management model. I'm not going to get this very right. The necessity of a different scheduler is because of the different threading model. They needed everything in the system to be non-blocking. So even that synchronous network call to Twitter, right? To the developer, it feels like it's synchronous, but behind the scenes, it's natively async. So the outbound call, after the outbound call is done, it releases that particular worker thread, and then when the response shows up on the socket, there's a new worker thread that's allocated. So it needed a new kind of scheduler, it needed a new kind of threading model associated with that. So those are the primary things that they did. And the bytecode that they generate is a custom bytecode format to be native to that. The reason we're going to LLVM is that frankly the JVM brings along too much overhead for the performance that we want to get. So right now, like a hello world, if you just did this versus Spring, we're about 30% more transactions per second on a Spring versus this, and the binary is a lot smaller. But the boot time is a little bit too long. It turns out that if you can get the boot time on one of these services, we're about like a few hundred milliseconds on this. If you can get the boot time down to 90 milliseconds, then it turns out that in a cloud-native world, if you start running out of memory, it's cheaper to self-destruct than it is to garbage collect. And so when we can get down to an LLVM implementation, we can actually reduce the boot time down to roughly 85, 90 milliseconds on these things, have an overall smaller memory footprint, and that gets closer to some of the performance goals that we've got with it.
Thank you.